7 equations that explain everything. 1. Pythagorean equation. This equation was formulated by Pythagoras. It underlies the Pythagorean theorem. It describes the relationship between the two legs of a right triangle and its hypotenuse. The hypotenuse is the side opposite the right angle. It makes up one side of a square. The area of that square equals the combined areas of the squares on the other two sides. The theorem is the basis of geometry and algebra. 2. Mass-energy equivalence. E equals mc squared is the most famous formula in the world. It was discovered by Albert Einstein in 1905. Energy is equal to mass times the speed of light squared. This means that changes in mass will result in changes in energy. Any object contains potential energy. Under the right conditions, energy can become mass. It also works the other way around. Pure energy is electromagnetic radiation, traveling at the speed of light. Einstein's equation enabled us to obtain nuclear energy. 3. Friedmann's equations. These expressions were formulated by Alexander Friedmann in the 1920s. Friedmann relied on Einstein's theories of relativity. His formulas describe the expansion of the universe. They combine all the factors of the cosmos: curvature, matter and energy, rate of expansion, etc. Friedmann's equations led to the discovery of dark energy. 4. Law of universal gravitation. This is the law formulated by Isaac Newton in 1686. It states that every particle attracts every other particle. The force of that attraction is directly proportional to the product of their masses. It's inversely proportional to the square of the distance between their centers. The equation describes all motion in the universe. It's been superseded by Einstein's theory of general relativity, but relativity is used when extreme accuracy is required. Newton's law perfectly describes most routine interactions. 5. Shannon's information equation. You've probably heard of the zeros and ones that make up computer bits. You can thank American mathematician Claude Shannon for that. In a seminal 1948 paper, Shannon laid out this equation. It shows the maximum efficiency at which information can be transmitted. C equals B times 2 log 1 plus S over N. C is the achievable capacity of a particular information channel. B is the bandwidth of the line. S is the average signal power. N is the average noise power. Sn gives the signal to noise ratio of the system. The output is in units of bits per second. 6. Second law of thermodynamics. The first law states that energy must always be conserved. The second law was originally used to describe heat transfer in a system. It established the concept of entropy. In a thermodynamic system, there's always heat and energy loss. Heat always flows in one direction only. The entropy of isolated systems can't decrease. If we stop heating something, it will inevitably cool down. This means the heat death of the universe is inevitable. Once the universe expands too far, there won't be enough mass and energy. 7. Maxwell's equations. James Clerk Maxwell studied electricity and magnetism. These forces were poorly understood in the 1800s. In 1864, Maxwell published a list of 20 equations. They described how electricity and magnetism worked. The formulas also showed their interrelation. Maxwell's 4 most important equations are still taught in college. They provide a basis for every piece of electronics in our world.